example 2. Simplify 4 plus the square root of 3 over the square root of 2. Once again, it says simplify, and the reason it isn't simplified is there's a denominator with a square root of 2. We're not allowed to have square roots in the denominator. So just like the last problem, the fix is I got to multiply by the square root of 2 to make that into just 2 without a radical. The requirement if I multiply the bottom is to multiply the top by the same thing. This time the top is 4 plus the square root of 3. This is a binomial. So when I multiply the top, I'm required to do the distributive property, multiplying the square root of 2 not just by 4 but also by the square root of 3. So if I do the math here, positive 4 times positive square root of 2 makes 4 times the square root of 2. Numbers outside radicals and numbers inside radicals do not interact with each other, so all I can do is stick those together. When I multiply the square root of 2 times the square root of 3, they're both positive, so I get a positive. These are both underneath the radicals, so I'm allowed to multiply underneath. 3 times 2 is 6. They both are within the radicals, so they're allowed to interact with each other. On the bottom, square root of 2 times the square root of 2 makes 2. Once again, you want to look to possibly reduce, but it's not often they do reduce. The three objects are the black and the red and the blue. The numbers inside the radicals don't come into play when you're trying to reduce. Only numbers outside the radicals matter. 4, this is a 1 and a 2. Does any number evenly divide 4, 1, and 2 other than 1? 2 divides 4 and 2, but not 1. Okay? So only 1 would, right? And we can't reduce by 1. So this is not reducible. That would be the best final answer right there. These are also checkable. And if you want to check them, real simple. This is supposed to be the same value as that. So if I type that in my calculator, I've got to type it in like this, parentheses, 4 plus the square root of 3. Now the square root on most calculators puts this beginning parentheses for the square root, end parentheses finishes the square root, another end parentheses finishes the numerator, so that's the binomial on top, all divided by the square root of 2. Again, square root parentheses 2, end parentheses equals. So the original expression, that, is equal to 4.053171996. If I'm right, this should have the exact same value. Parentheses, 4 square root 2, end the square root, plus square root of 6, end the square root, and the numerator, divided by 2. And they're equivalent. 2 is not a radical, so that verifies that I got the correct answer.